All right, so this is it. This is where we're going to define the derivative. This is so exciting. The derivative of f at a, which the way we're going to denote that is f prime of a. So when we see that apostrophe right there, we're going to read that as f prime of a, is given by the following limits. So one is just the same limit that we've been looking at. So f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a, all divided by h. You can also use this definition, the limit as x approaches a of f of x minus f of a, all over x minus a. I don't really like this second definition as much, the second limit, but it is one that you can use. One other term that we need to know here is that if f prime of a exists, we say that f is differentiable at a. So if I say that a function is differentiable at a certain point, all that I'm really saying is that the derivative of f at a exists. So another way of saying that is, well, f prime of a exists. So that's all that means if I say f is differentiable. So let's see if we can use this here. Example 3 says, for each function, find the derivative at the given value of a, and then use that to write the equation of the tangent line at x equals a. So okay, I want to use this derivative, and I'm going to use this highlighted version, the one we've been using. So here, I'm going to think about, let's see, step 1. Let's look at g of 2 plus h here. So I'm going to look at g of 2 plus h. A is 2 here, that's how I came up with that. So I'm just going to plug 2 plus h in for g of x. 1 over 3 times 2 plus h minus 1. 1 over 6 plus h minus 1. I have 1 over 5 plus h. So again, you'll get to a point, you'll say, well, I can't simplify this anymore, so maybe we'll move on to the next step. The next step then would be, let's go find f of a. So in this case, what is g of 2 here? What is g of 2? So 1 over 3 times 2 minus 1. This is 1 over 6 minus 1. This is 1 over 5. So I want to look at this numerator now. I'm going to take the two things that I've just found. I'm going to subtract those two. So I'm going to take g of 2 plus h minus g of 2. So what does that look like? 1 over 5 plus h minus 1 over 5. And this looks kind of ugly. There's really not a great way to simplify this here. Even though the denominators, you might say, well, they both have a 5, right? Can't I just like add an h in over here plus h or something like that? And unfortunately, no, it's just not going to work out that way. My suggestion to you is to find a common denominator here. If you don't find one now, we're going to have to do it later, and the expression is only going to get more complicated from here. So the way I'm going to do that is multiply this function, or excuse me, this term over here by 5 over 5. And over here, I'll multiply the right-hand term by 5 plus h over 5 plus h. So let's see what we end up with. 5 times 1, I'll have 5. Your denominator, I'm actually going to tell you, don't worry about that. I'm going to leave that as 5 times 5 plus h. If you want to distribute those, you absolutely can. Go right on ahead. But I'm just going to leave that as 5 times 5 plus h minus, let's see, what do I have over here? 1 times 5 plus h. Well, that's just going to be 5 plus h. So 5 plus h divided by, again, I'm going to keep that denominator as 5 times 5 plus h. Be really careful here with this minus sign, because really what this means is I want to subtract 5 and I want to subtract h. So I'm not the biggest fan of subtraction. What I will do most of the time is I'll say, you know what, let's take this, make it a plus, and then let's just change both of the signs that follow that negative sign, or all of the signs that follow that negative. And hopefully we look at this, we say, well, 5 plus negative 5, well, look at that, those two cancel. And here I've got negative h all over 5 times 5 plus h. So okay, there is my end of step 2. Oh my good, that was only step 2. So I've been looking at the numerator. Now I'm going to say, well, what happens if I divide what I just found by h? So now I'm going to take g of 2 plus h minus g of 2, take that whole thing and divide it by h. So this is going to look a little bit ugly here, because this piece that I want to know, that numerator, is actually this whole fraction. It's actually just what I found. So I need to take that and plug this in. It's going to look a little messy, but let's see. I'll have negative h divided by 5 times 5 plus h divided by h. This is really what I have. And that just doesn't look very nice. So the way I think about this, look at that denominator. I'm going to force that denominator to be a fraction. And division, like I have right here, or excuse me, this fraction right here is just another way to write division. So how do I divide by a fraction? Well, we multiply by the reciprocal. So I can think about this as just multiplying by 1 over h, multiplying by 1 over h. In the denominator, those two will cancel, and in my numerator, hey, look at this. H in my numerator cancels, h in the denominator cancels. Boy, that's starting to feel awful familiar, huh? I wonder if that's going to be an important idea later on. But what does that leave me with now? Here in my numerator, I really have negative 1. At this point, that's the only thing that's left, negative 1 divided by 5 times 5 plus h. So the last step then, step 4, we want to look at the limit as h approaches 0 of this expression of g of 2 plus h minus g of 2 divided by h. I'm not going to ask you to write out all of these steps here, so write out the whole function each and every time, but I will say I do think it's helpful in memorizing the limit definition of the derivative, and I do really think it helps you to kind of understand exactly what you're doing in every single step. You kind of understand you're adding in a little piece of the puzzle every single time instead of just, well, I'm going to subtract by this number because Mr. Huber told me to. So I'm going to look at the limit as h approaches 0 of negative 1 over 5 times 5 plus h. This is negative 1 over 5 times 5 plus 0. This is negative 1 over 25. Oh my gosh, okay. So there is my derivative. This is actually f prime of, what do we say, f prime of 2, I believe? I already forgot. Or excuse me, g prime of 2, right? Our function was g. So g prime of 2. Holy moly. Okay. So g prime of 2 is equal to negative 1 over 25. There's the first part of my answer. The next part said, and use this to write the equation of the tangent line at x equal... Oh my gosh, we're not even done. All right, well, let's keep going. The equation of the tangent line now. Notice in this problem, notice that they only gave me an x value here. They did not give me a y value. So right now, at this point, I have g prime of 2. I know that this is the slope. I have a point 2 comma blank. I'm really missing this y value. What is this y value here? So I need to go find that before I can write the equation of the tangent line. I need the full point. The way I do that is I'm going to take this 2, and I'm going to plug that into my function. I'm going to evaluate g of 2. So I have to double check my function because I've already forgotten what it was. 1 over 3x minus 1. Okay. So 1 over 3 times 2 minus 1. This is 1 over 6 minus 1. This is 1/5. So this is my y value here. So if you want to find the y value, you need to take that x value and plug it back into the original function. This is going to be an important idea for us in the sections to come. And at this point, I should have everything that I need to write the equation of the tangent line. So y minus y1, so let's see, y minus my y value would be 1/5 equals m, my slope, that's -1/25, times x minus my x coordinate is 2. And I'm just going to solve for y here very quickly. Y minus 1/5 equals -1/25x plus 2/25. I want to add 1/5. I'm really adding 1/5. But I need a common denominator, so that's really the same as adding 5/25. So I should have y equals -1/25x plus 7/25. So there is the equation of my tangent line to my function g of x at x equals 2. So these problems do tend to get very lengthy. It's very easy to make a mistake, and so that's why it's really important that you show your work. I am going to be asking that you show me your work on the exam for this exact reason, because if you miss it, you could miss something as small as a negative sign and everything else falls apart. But let's suppose that at the very beginning of my problem, what if I said, oh, I am so sorry. This is so embarrassing. I'm so sorry. I actually meant to write a equals 3. Oh, gosh, I'm so sorry. Can you please redo the problem for me? And you would be frustrated and upset with me, and rightfully so, because if I wanted to change the x value that I was talking about, I'd have to redo everything that I've done here. All of the steps, everything that I've done, I'd have to redo over and over again. Right? So if I change that one x value, if I change this guy right here, I have to redo the entire problem. So in the next section, what we're going to look at is we're going to see, okay, how can we take this derivative? How can we kind of keep ourselves from having to do that? Can we come up with a way so that we can change this x value so that we don't have to redo the entire problem if I want to just change my x value ever so slightly? And that's what we're going to look at in the next section.